Hello everyone, I hope everybody is fine and I hope you have practiced enough on techniques of factoring, and we're going to continue with one really nice shortcut method for factoring quadratic trinomials. We have a quadratic trinomial 21x squared minus 22x plus or minus 8. We want to factor this, and we're making a nice chart like this, and just like the decomposition method, P and S are letters standing for product and sum. So we're going to find the combination of numbers whose product is 21 times negative 8, which is actually negative 168. So if you remember, we used to multiply 21 by negative 8, and that would be the product of the two numbers we're looking for, and the sum was negative 22. Okay, so now if you have a calculator and you start dividing negative 168 in a row by 1, 2, 3, 4, 5, 6, 7, 8, 9, quickly dividing using your calculator, you will find a combination that would give you a sum of negative 22. So for example, when you divide negative 168 by 1, you get negative 168. So the product of 1 and negative 168 is, of course, negative 168. It works. But the sum is negative 167. But we want a sum of negative 22. So we see that that doesn't work. So you're going to divide probably negative 168 by 2 now instead of 1. And that will give you 84, negative 84. But negative 84 plus 2 is negative 82. It's not negative 22. So we see that that combination doesn't work either. So quickly with the calculator, we're going to continue dividing by 3, 4, 5, 6, and so on and so forth, until we find a combination of numbers whose sum is negative 22, just like before. Nothing is new here. So if you try a couple of times, you will see that if you divide it by 6, you get negative 28. So the two numbers that add up to negative 22 are negative 28 and 6 actually. Add them up, it's negative 22. Multiply them, it's negative 168. So we got the combination of numbers we looked for, just like decomposition method. Now the rest is very easy, and that's why we call this shortcut method. Whatever value the a has, a is the coefficient of x squared term. A here is 21. Whatever that number is, you are going to rewrite it here, 21, 21. If it's like 5x squared, you put down 5, 5. If it's like 10x squared, you put 10, 10. As simple as that. And these two numbers that we just got, we're going to repeat them here. We're going to place them in the box, and we're going to try to see if we can sort of reduce these numbers by dividing them by their GCF. The two numbers, 21 and negative 28, I think they have something in common, and that is 7. 7 is the greatest common factor. So we can say 7 goes into 21 3 times, and 7 goes into negative 28 4 times, with the negative sign in front, of course, right? So we sort of divided both of them by 21 because their greatest common factor was, we divided by 7 because their greatest common factor was 7. And here, 21 and 6, what do they have in common? Well, I would say 3 times 7 is 21, 3 times 2 is 6. So 3 is the GCF greatest common factor between them. So if you divide 21 by 3, you get 7. You divide 6 by 3, you get 2, of course. So that means that 3 right there, x minus 4, that's in the box over there, times 7x plus 2 would be the answer to this factoring question. So it's not like decomposition method. You don't need to show like steps. You don't need to follow any standard procedure. It's just like this quick trick of just reducing the numbers, dividing them by their GCFs, and whatever answer you got in those final boxes, that will be in the form of the product of two binomials, and that's the final answer. Let's quickly try this one. So for this one, I'm going to go 15 times negative 15. That's negative 225. So that's the product. The sum is negative 16. So I have my calculator. So I quickly punch in negative 225. I divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to look for a combination of numbers that would give me a sum of negative 16. If you do this very quickly using your calculator, you'll see that if you divide it by 9, negative 225 divided by 9, it gives you negative 25. So negative 25 times 9 is actually negative 225. And when you add them up, it's actually negative 16. So bingo, again, we got the combination we wanted. 15, as I said in the past, it's going to be repeated in these boxes. Okay, whatever number that is, blindly you're going to put it in these boxes. And these two numbers, negative 25 and 9, we just write them down here. And we just look for GCFs. 15 and negative 25, clearly they have GCF of 5. So 3 times 5 is 15. 5 times 5 is negative 25. 5 times negative 5 is negative 25. So I'm going to divide both of them by 5. So I get 3 here. I get negative 5 there. These two have 3 in common again. So I go 5. That's 5 times 3 is 15. And this is 3. Therefore, the answer would be right there in that dashed ellipse over there. So 3x minus 5. And then times 5x plus 3. There we go. That is the final answer. Very quickly, I could find it. When you keep practicing, you can do this much faster. And it's probably faster than the decomposition method because you don't need to show some steps. It's a cool method. It's a shortcut method. End of the day, I thought I share it with you. It doesn't harm. There is another shortcut method. Now that we're talking about shortcuts, this one is called guess and check method. It's a popular method, sometimes known as actually trial and error method as well. Let's say we have something like 2x squared minus 23x plus 30, okay? So in this method, what we do, we're going to start thinking. We're going to say, okay, what are those two numbers whose product could be 2? You may say it's 2 and 1, and you are right. You may say it could be 1 times 2, you are right. You may say negative 1 times negative 2, you are right. There's a whole bunch of combinations that will give you a product of 2, and that's the A value, the leading coefficient, the coefficient of x squared. Now, we say the same thing for 30. What combination of numbers would give you 30? You can say 3 times 10, and of course, you are right. It could be 10 times 3. It could be negative 10, negative 3, you know. It could be actually negative 3 and negative 10, or it could be actually 2 times 15. And a whole bunch of combinations are there. Now, the thing is that we're looking for a combination that would give you the middle term after we do some sort of crisscrossing here. So 2 times 10 is like 20. 20 plus 3 times 1 is 23. But we have here negative 23. So you see that combination doesn't work. So we're going to try this other combination, 10 and 3. 2 times 3 is 6. 6 plus 10 times 1 is 16. But we don't have 16 in the middle. So that combination doesn't work either. We try the next one. Maybe the next one would work. 2 times negative 3 is negative 6. Negative 10 times 1 is negative 10. Add them up. It's going to be how much? Negative 16. Again, it doesn't work. We try this other one. 2 times negative 10 is negative 20. Negative 20 plus negative 1 times 3 is negative, actually 23. Bingo, we got it. So now that we got the right combination, so this 2 works with that negative 3, and this 1 worked with that negative 10, basically, right? So now we can say the answer is 2x minus 3 times 1x minus 10. This should be the final answer, of course, for this factoring question. So I know you may say we tried so many combinations, but remember, you don't have to write all of these combinations down. Everything is done mentally. It's a trial and error method. It's a guess and check method. Very often in your mind, you can think of these combinations and quickly in your mind do the crisscrossing and then see if you can get that middle number, in this case negative 23, and then as soon as you find that combination that works and gives you the middle term, then you're going to quickly announce 2x minus 3, in this case 1x minus 10, the product would be the answer. So this is another shortcut method for factoring these kind of trinomials. There is even another one, and this one is called Australian method. So I would say number 9. These are all shortcut methods. Australian method it's called. Okay, for example, if I have something, let's say 6x squared plus 11x minus 2, what we do is this. We just grab, we draw a bar line and we open and close 2 empty brackets. And whatever is the coefficient of x squared, in this case 6, we're going to write it 3 times. So once here, once here, once here. Inside the brackets, one on the bottom. And then we look for that so-called P and S again. So P, in this case, the product has to be 6 times negative 2, which is negative 12. And the sum has to be 11. So the question is, what are those two numbers that add up to 11, but their product is negative 12? So what could be those numbers? The product is negative 12. Well, could it be negative 3 times negative 4? Could it be what? The combination clearly is positive 12 times negative 1. Because positive 12, let me write it down here, positive 12 and negative 1, when you multiply them, you get negative 12, and the sum is actually positive 11. So the moment you got that, basically this is the final answer. Let me put the x's here, so the x's are there. And the only thing you have to do is to simplify this answer. For example, here we have a common factor of 6, which I can factor out. So that gives you 6 times x plus 2. And this 6 with that 6 at the bottom, they cancel out each other. You simplify the fraction, and you end up with x plus 2 simply left over times 6x minus 1. And that is, again, the final answer. So this is just another shortcut method known as Australian method. Now, you don't have to learn these shortcut methods. I just explain them just for the sake of interest of some students, or if you want to do factoring questions much faster using like cool methods. But you can always stick to that traditional decomposition method and factor quadratic trinomials that way. But these are also some valid techniques you can always use for factoring. And don't forget, it just requires practicing. So first time I explain, you may say, okay, you get it, but you got to practice so that you become fluent in it, just like everything else in life. Thank you very much.